All right, I wanted to make sure you understood how Zern was explaining the moving of the tens and give you an opportunity to practice with the traditional algorithm on your own a little bit more. So the first problem we're gonna look at is 50 divided by 2. Okay, we're gonna do 50 divided by 2. I'm gonna show you what this is gonna look like with the discs. So we have the tens and the ones. I have 5 tens, 2, 3, 4, 5. I'm going to then break this into 2 groups. Okay, group 1, group 2. Now, I can evenly put 2 tens in each group. However, I still have this 1 10 left over. This is what they're talking about. You're unbundling this and turning it into individual ones so that you can easily split it up. Now, when I have 10 ones, I can split that into 2 groups. So I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then I have 25, okay? Now, it's not too much difference necessarily with the traditional algorithm. There's just something down there when you bring down. So I'm gonna divide first. 2 goes into 5 how many times without going over? Well, 2 isn't gonna fit into 5 perfectly, but I can put it in there 2 times without going over. So I'm gonna put 2 times 2 here. 2 times 2 gives me 4. So I'm multiplying, then I'm putting it down here so I can subtract. 5 take away 4 gives me 1. Now I'm gonna bring it down and I have 10. 2 times what gives me 10? Well, 2 times 5. I'm gonna write my 10 here so I can subtract, and then I have 0 left over. There's nothing to repeat and there is no remainder. So 25 is my answer. Let's look at another one. 75 divided by 3. I'm gonna show you what it looks like here. You're gonna do the traditional algorithm on your own. Tens, ones. I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5 ones. 1, 2, 3. 3 groups that it's being divided into. I can easily put 2 tens in each group. Oops. I can easily put 2 tens in each group. But then I still have this 1 10 left over. I'm gonna break it down into ones so that it's easier to share. Now I have 15 ones. Well, I can put 5 ones in each. And I have my answer. I'm not gonna tell you what the answer is, but I have my answer. Now you go ahead and solve this on your own with the traditional algorithm. All right. So I have 3 going into 7. Well, 3 doesn't go into 7 perfectly. So I'm gonna ask myself, what can I get that's as close as possible without going over? 3 times 2, multiplying, gives me 6. Then I subtract and I have 7, take away 6 gives me 1. Bringing down the 5. Now I'm asking myself 3 times what gives me 15? Well, this one, luckily, after I'm repeating, I can do perfectly. 3 times 5 gives me 15. Subtracting 15. And there's no repeating and no remainder. So 25 is my answer. There's one more. Here is the problem. 92 divided by 4. I am going to have you do this one completely on your own. If you do not want to do the discs, you don't have to, but I do want you to do the traditional algorithm. So go ahead and solve this one on your own. All right, so I'm gonna go ahead and show it to you with the discs first. 10s and 1s. I have 9 10s. And I'm gonna give myself a little room. 2, 3, 4, okay? So I'm gonna split this up. Well, I can easily put 2 in each. But then I have one more, splitting this as 10s. Now I have 12 ones divided by 4. Well, that's 3 in each. And I get 23. So let's take a look at the traditional algorithm with this. 4 goes into 9 how many times? Well, it'll fit in there twice, but it's not gonna go in perfectly. 4 times 2 gives me 8. I'm multiplying. Now I'm subtracting. 9 take away 8 gives me 1. Bringing down my 12, or my 2 to make a 12. Now I'm going to repeat. 4 times what gives me 12? Well, 3 goes in there nice and perfectly. 4 times 3 gives me 12. Now I'm going to subtract. I have 0. There is nothing else to bring down. There is no need to repeat, and there's no remainder. So my answer is 23. So that is what happens when things don't go in evenly. And sometimes you have to move things over with a 10.